All right, in this video, we are going to work the following problem. It says which expression is equivalent to the quantity 1 plus tan theta times the tangent of 2 theta for all values of theta for which this expression is defined. Okay, and so we're given a bunch of choices here. So what we want to do is just try to simplify this and match it to one of these choices here. So looking at this expression, 1 plus tan theta times tan 2 theta, I can see that I have what appears to be something that I might use the double angle identity on. I have tangent of 2 theta. So looking at the identities and the double angle identities for tangent, right? I have tan 2x equals, you can pick any one of these three things here. And so looking at this one, I have this first one, which is all tans, this one, which is all cotangents, and this one, which is mixed cotangents and tangents. So looking at my choices that I have cosecant squared, tan squared, and tangent. So in my answer choices, I have only tangent. I don't have any cotangents at all. So what I'm going to do is pick this first one right here, right? Because it has only tangents in there. Now, whether that's the right thing to do or not, it could wind up to be a cotangent in there. But for right now, this just seems kind of like the thing that you would want to do. So that's what I'm going to do. I'm going to go in to the expression and replace tan 2 theta with 2 tan theta, 1 minus tan squared theta. Like so. Okay. All right, so that's what I've got. So now that looks a lot more complicated. It has this fractional expression in here. And so the question is, okay, well, what would I do next? Okay. And so here is kind of a trick that you need to know. We've seen it before in the section on the first section that we did on identities, kind of, and that was to in that section we multiplied through by sort of the same parts, but with different signs or operations joining the same parts. The conjugate is kind of a way to think about it. And so that is something that might be done here. So for instance, we had like 1 plus sine x in the bottom part of a fraction. We multiplied top and bottom by 1 minus sine x. And that gave us a 1 minus sine squared that we could switch over to cosine squared. The problem, though, with 1 minus tan squared, if I go back and look at that approach, you can see that tan squared is already by itself on one side of this Pythagorean identity. So if it were tan squared plus 1, then I would just go ahead and try and replace that by secant squared and see if that worked out, because that might be the way to do it. But with tan squared minus 1, I'm just not going to be able to use this. It doesn't matter how you rearrange this. There's probably not going to be much that's very useful here. All right, so what you want to do, right, the trick I'm going to show you is to factor this expression, okay? So if you look at that expression, 1 minus tan squared theta, it kind of has the form, right, of 1 minus something squared. All right, so if you write that 1 minus something, which I'm going to call x, right, because x is an unknown here, so 1 minus something squared. This expression, 1 minus tan squared theta, has this same format, okay? Exactly the same. And now if you look at this expression, that is the difference of two squares. And so it can be factored, right? 1 minus x squared can be factored to 1 minus x times 1 plus x, right? Because it is the difference of two squares. So from algebra class, right, college algebra, we know that that can be factored in that way. All right, so what that says is that this expression can also be factored in the very same way here. So when you're first seeing this, then it might be, kind of odd to think about factoring this. So you might not recognize the fact that hey, this can be factored in exactly the same way. Whereas if you see it in this format right here, almost everybody is going to say, hey, yeah, that's just the difference of two squares, right, from college algebra, and I can factor it like that. And so what this gives us is a little pattern for factoring this expression here as well. Okay, so that's exactly what I'm going to do. All right, so this expression is going to be 1 times tan theta, 2 tan theta on top. And on the bottom, now I am going to factor. All right, so if you, in this case, right, this expression 1 minus tan squared, 1 is playing the role of 1 in this case, right? And tan theta is playing the role of x in this case, right? Because here I have x being squared, here I have tan theta being squared. So tan theta is playing the role of x. So that means when you factor it, it's going to be 1 minus tan theta one plus tan theta, like so. All right, and so this expression 1 minus tan squared theta factors into these two binomials, okay? Or two-term factors, okay? So if you don't believe me, right, you can FOIL this out for yourself. 1 times 1 is 1. The outer would be tan theta. The inner would be minus tan theta. And so the outer and the inner cancel each other out. And then when I do last times last, I get minus tan theta times tan theta. That is minus tan squared theta. All right. So if you're shaky on factoring expressions, applying factoring to these trigonometric expressions like that, you can always check yourself by multiplying it back out and seeing that they're equal to each other. All right, so now that's a huge help. Excuse me. That's a huge help because now the next thing I would do is to go ahead and multiply these two fractions together. Remember, I can think of that expression as a fraction if I put it over 1. And now everything is completely factored here. I can't factor any of these expressions anymore. Right, and so I can see that, hey, I have some common factors between the top and the bottom, right? In the numerator, I have a factor of 1 plus tan theta, and in the denominator, I also have a factor of 1 plus tan theta, right? And so therefore, I have a common factor, right? Between the numerator and denominator, I can cancel those out, right? And each time they go into themselves one time, right? And so now this expression is simplified. To multiply on the top, it's 1 times 2 tan theta. So that's just going to be 2 tan theta. On the bottom, right, I have 1 times 1 minus tan theta times 1. And so that's just going to be 1 times tan theta. All right, so that is looking pretty simple here. Let's go back and check our answer choices. Right, and if you look down here at the very bottom, 2 tan theta, 1 minus tan theta, that is exactly one of our choices. So that is good. We are done, and that's the answer here. All right, so just keep in mind, right, if you have these expressions that look like this, that they can be factored, and you would factor them pretty much exactly the same way as you did back in college algebra class, okay?